No secret that endotoxin testing is a challenging and inefficient process. Manual test setup requires hundreds of pipetting steps and is difficult for consistency. And manual testing is prone to mistakes and costly retests. Plus, it takes way too long, about 60 minutes, just to manually start each assay. Hello, my name is Hayden Skowski, and I am the Global Application Specialist here at Sievers Analytical Instruments. In this short video, I'm going to explain how microfluidic automation works and why it is the clear answer to making endotoxin testing quick and efficient. So microfluidic automation is automation using a centripetal microfluidic platform, which is going to be the simplest form of BET automation available to the market today. Now, current manual test setup requires hundreds of pipetting steps and is often super difficult for consistency, and manual testing is often prone to mistakes and costly retests. The Sievers Eclipse is a great application for BET. It allows users to automate endotoxin testing without robotics. Now, microfluidic automation is going to be the clear answer to making endotoxin testing automated and more quick and more efficient. It leverages a network of microchannels to direct and mix fluids to automate endotoxin assays, taking a drastic burden off of the analyst and reducing hands-on time and also pipetting time. Microfluidic technology is achieved within a small, compact microplate that is analyzed using an incubating benchtop spectrophotometer similar in size and function to absorbance microplate readers that's going to be used for traditional LAL assays. Now, the Sievers Eclipse comes with a microplate that is preloaded. It has a standard curve with RSE from 50 EU down to 0.005 EU per mil. And every sample comes with a PPC, or a positive product control, and duplicate. Once the analyst is ready to run the assay, all they have to do is reconstitute their standard curve with LEO reagent water, and then add their samples, and then add their LEO reagent, which is going to be 1 mil for 21 samples. Once that is done, the analyst will hit go, and the microfluidic liquid handling does all the work. It will measure everything, it will mix the samples with the lysate, and it will give you readings in the software throughout the entire assay. The instrument will rotate the microplate, and the microfluidic chambers and the centripetal force will move and measure the liquids by building pressure. Once the samples and LEL is dispersed initially, the instrument will slow down and the plate will slow, and that's going to release all that pressure that was built up, and it will precisely dispense samples and LEL in a 1-to-1 ratio into the optical wells. Once that is done, the instrument is going to oscillate or move back and forth to achieve a homogeneous mixture, and once samples and standards are mixed with the LEL in the reaction in optical wells, the kinetic chromogenic assay will begin. Now, in short, this form of microfluidic automation handles the tedious liquid measurement, flow, and mixing, but nothing changes in terms of the biochemistry versus the traditional 96-well plate chromogenic method. This automation process enables assay setup in just 9 minutes. That means you can run 4 assays a day. You'll save about 3 hours and 20 minutes of valuable time. What would you do with those extra hours? Only 1 milliliter of LEL reagent is needed for 21 samples. So you can run up to 63 samples with just 1 vial of lysate on the Sievers Eclipse. Microfluidic automation is accurate, cost-effective, reliable, and sensitive. It manipulates small reaction volumes within narrow channels, and by doing so, can reduce your cost and consumption of reagents and samples, and also decrease time setting up your plate. You don't have to change any of the reagents that you're currently using because the Sievers Eclipse uses the same reagents as your traditional 96-well plate kinetic chromogenic method. To learn more about how the Sievers Eclipse automation platform uses microfluidic automation, download our buyer's guide.